Look at something across the room right now. A clock on the wall. A word on a label. The face of someone you love. Is it sharp? Or is there a soft haze around the edges that wasn't there 5 years ago? Most people with blurry vision do the same thing. They go to the eye doctor. They get a stronger prescription. They buy new glasses. 6 months later, the prescription needs updating again. And again. And again. Here is what almost nobody tells those people. The glasses are not treating your vision problem. They are compensating for it. And the reason your vision keeps deteriorating, the actual biological reason, has almost nothing to do with your eyes. It has everything to do with what is happening in your blood right now, while you are watching this. You have probably heard diabetes mentioned in connection with vision loss. But here is what that conversation almost never includes. You do not need to be diabetic for blood sugar to be quietly destroying your eyesight. You don't need a diagnosis. You don't need elevated fasting glucose on a lab report. You need something far more subtle and far more common. Blood sugar that spikes and crashes throughout the day. That runs slightly too high for slightly too long. That chronically floods certain tissues with glucose while leaving others starved. Research suggests that pattern affects the majority of people over 55. And it quietly targets the most metabolically vulnerable tissue in your entire body. Your eyes. The retina, the thin sheet of light-sensitive tissue at the back of your eye, has the higher metabolic demand of any tissue in the human body. Gram for gram, it consumes more oxygen and more glucose than your brain. It is extraordinarily active and extraordinarily sensitive. When glucose becomes dysregulated, the retina pays the first price. In this video, I am going to walk you through the 5 specific biological mechanisms by which blood sugar is degrading your vision right now, and the exact protocol that addresses each one. By the end, you will have a 5-step plan you can start tonight, not next month, tonight. But before we go any further, I need to stop and name something critical. If any of these apply to you, stop watching and call a doctor today. Not tomorrow. Today. Sudden vision loss in one eye. A curtain or shadow moving across your visual field. A sudden flood of new floaters, dozens of dark spots appearing at once. Flashing lights in your peripheral vision that come and go. Any one of those signs points to acute retinal damage or detachment. These are emergencies. No protocol in this video applies to those situations. You need a same-day ophthalmology evaluation. If none of those apply to you, if what you have is gradual blurring, difficulty reading fine print, halos around lights at night, or a general haziness your glasses no longer fully correct, then stay with me. Because what I am about to describe is almost certainly happening in your body right now. Mechanism 1. Your lens is physically inflating after every meal. Your eye's lens, the transparent structure behind your pupil that focuses light onto the retina, is made almost entirely of water and protein. It has no blood vessels. It cannot receive nutrients from circulation the way your organs do. Instead, it absorbs glucose directly from the fluid surrounding it. When blood glucose rises rapidly after a meal, that glucose enters the lens in excess. Inside the lens, it gets converted by an enzyme into a compound called sorbitol. Here is the problem. Sorbitol cannot leave the lens. It has no exit route. It accumulates. And because it pulls water toward itself the way a dry sponge draws moisture, the lens physically absorbs water and swells. A swollen lens cannot focus correctly. The focal point shifts. Print that you could read in good light becomes a blur. This is not permanent structural damage. It is a fluid shift. It is reversible. And it explains something that confuses millions of people. Why is vision noticeably worse some days than others? Why is it sharper in the morning before eating than in the late afternoon? Why does a prescription from 6 months ago suddenly feel wrong? Your vision is not randomly changing. Your lens is inflating and deflating based on your blood sugar. The optometrist measuring your refraction on one specific day has no idea which version of your lens they are measuring. Mechanism 2. The finest blood vessels in your body are slowly turning to ceramic. The retina is fed by the smallest blood vessels in the human body. Capillaries so fine that red blood cells pass through them single file. These vessels are the lifeline of your entire visual system. Without them, the 130 million photoreceptors in your retina receive no oxygen, no fuel, and no repair capacity. Chronically elevated blood sugar damages these capillaries through a process called glycation. Glycation is what happens when glucose molecules chemically bond to proteins and fats, deforming their structure, rendering them stiff and dysfunctional. Think of it this way. Your capillary walls are built from flexible proteins, designed to expand, contract, and remain intact under pressure. When glucose glycates those proteins, the walls stiffen and thicken. Like a rubber hose that slowly turns to ceramic. It loses its flexibility. It becomes brittle. It develops leaks. When the capillaries feeding your retina begin to leak, fluid and blood seep into the surrounding tissue. The retina swells. Visual signals become distorted. This is the beginning of what clinicians call diabetic retinopathy. But here is what the clinical system will not tell you. The underlying process begins years, sometimes decades, before any diagnosis is made. You do not need a diabetes diagnosis for this to be happening to you right now. You need cumulative glycation exposure. And cumulative glycation exposure is a function of how high your blood sugar runs, how often, and for how long, not whether a number on a lab test has crossed a clinical threshold. Mechanism 3. Your macula's built-in filter is being depleted faster than you can replenish it. The macula is the small central region of your retina responsible for your sharpest, most detailed vision. Reading. Recognizing faces. Seeing fine print. The macula contains two pigments, lutein and zeaxanthin, that act as its primary defense against oxidative damage. They absorb blue and ultraviolet light before it can reach and damage the delicate photoreceptors underneath. They are your eye's built-in internal filter. Chronic blood sugar dysregulation floods retinal tissue with oxidative stress, an overproduction of chemically reactive molecules that damage cell structures. Lutein and zeaxanthin are consumed neutralizing those free radicals. They are depleted faster than the body can replenish them. And when the macula's protective filter runs low, light reaches the photoreceptors unfiltered. Damage accumulates. Visual acuity falls. Most people over 60 are already low in these pigments because their diets are low in dark leafy greens. Add blood sugar dysregulation, and the depletion accelerates dramatically. Mechanism 4. The same damage destroying your retina is running simultaneously in your kidneys, and raising the pressure inside your eye. The eye and the kidney share a critical biological feature. Both are heavily supplied by the same type of tiny vessel that is uniquely vulnerable to glycation damage. This is why, in people with long-standing blood sugar dysregulation, kidney function and retinal function tend to decline together. The same mechanism runs in both organs at the same time. But the connection goes further. When kidney function begins to decline, fluid retention increases, blood pressure rises, and the delicate pressure balance inside the eye, called intraocular pressure, is affected. Elevated intraocular pressure is the primary driver of glaucoma, the condition that progressively destroys the optic nerve. Glaucoma produces no pain. It takes peripheral vision first, so slowly that most people do not notice until significant damage has already occurred. The chain connecting blood sugar dysregulation, microvascular damage, kidney strain, elevated eye pressure, optic nerve injury is rarely presented as the single connected sequence it actually is. It is connected. And it starts with blood sugar. Mechanism 5. 3 nutrients are being silently drained from the tissues that protect your vision. Thiamine, vitamin B1, is essential for glucose metabolism in the specialized cells of the retina. When blood sugar is chronically elevated, thiamine is consumed at an accelerated rate, processing the excess glucose load. Research indicates a significant proportion of people with blood sugar dysregulation are functionally deficient in thiamine, even when standard blood levels appear normal, because tissue demand is outpacing supply. Thiamine deficiency in the retina impairs the ganglion cells that carry visual signals from the retina to the brain. The signal does not disappear. It degrades. Vision becomes less sharp, less crisp, even when the structural health of the eye appears intact on imaging. Magnesium is required for proper insulin signaling, meaning magnesium deficiency makes blood sugar dysregulation worse, which increases retinal damage, which depletes magnesium further. A progressively worsening loop. Clinical research estimates that the majority of Americans over 60 are insufficient in magnesium. Most have no idea because magnesium is not included on a standard metabolic panel. Zinc. The retina has one of the highest zinc concentrations of any tissue in the human body. It is essential for the visual cycle, the biochemical sequence by which light signals become neural signals, and for the enzymes that protect retinal tissue from oxidative damage. Zinc absorption decreases with age. When zinc falls low, the retina's antioxidant defenses weaken at exactly the moment they need to be strongest. 3 nutrients. All depleted by the same conditions driving the other 4 mechanisms. All replenishable through specific, accessible foods. The protocol. I want to tell you about someone I'll call Eleanor. 67 years old. Retired. Reasonably fit. No diabetes diagnosis. She went to her optometrist twice in 3 years and came away with a stronger prescription both times. She was told to eat more leafy greens and wear good sunglasses. She did both. The vision kept getting worse. When she described her symptoms more carefully, a pattern emerged. The blurring was always worse in the late afternoon. Noticeably better before breakfast. After a dinner of pasta, bread, and something sweet, the halos around the bedroom lamp were nearly unbearable. After a day of mostly protein and vegetables, her vision was measurably clearer. She had never connected those observations because nobody had told her that her lens was physically swelling after glucose spikes. Her fasting glucose was 102. Not diabetic. Not even pre-diabetic by most clinical definitions. A number that generates no intervention at a standard appointment. But her postprandial glucose, the spike after eating, had never been measured. And it is the spike, not the fasting number, that drives every mechanism we just covered. Eleanor followed this protocol for 4 months. The afternoon blurring reduced within the first 6 weeks. The halos diminished. Her drusen progression stabilized on her next imaging evaluation. Not reversed, the damage already done does not undo itself, but stopped. Because the environment causing it had changed. Here are your 5 steps. Start tonight. Step 1. Morning anchor meal. Before any simple carbohydrate, eat protein and fat first. 2 eggs with smoked fish, or full-fat plain yogurt with a tablespoon of ground flaxseed. This blunts the early glucose spike that inflates your lens in the first 2 hours after waking. The morning glucose response sets the metabolic tone for the rest of the day. Start it flat. Step 2. Sequence every meal. Fiber and protein first. Starch and sugar last. When you eat vegetables and protein at the start of a meal and starchy or sweet foods at the end, glucose enters the bloodstream at roughly half the rate. Same foods. Different sequence. Dramatically different retinal impact. This has been confirmed in multiple clinical studies. Step 3. Walk 10 minutes after dinner. Not a workout. A walk around the block. Muscle contraction during and after eating pulls glucose out of the bloodstream directly into muscle tissue without requiring insulin. A 10-minute walk after dinner reduces the postprandial glucose peak by a clinically meaningful amount. It is the lowest cost retinal protective intervention available to anyone. Step 4. 3 foods for the 3 depleted nutrients. A small handful of raw, unsalted pumpkin seeds in the afternoon, zinc and magnesium in a form the body recognizes. 2 egg yolks at breakfast, the single most bioavailable source of lutein and zeaxanthin available at any ordinary grocery store, more bioavailable than supplements, because the fat already in the yolk ensures full absorption. Herring 2 to 3 times per week, thiamine, vitamin D, and the omega-3 fatty acids that directly support retinal cell membrane integrity. Step 5. Stop eating 2.5 hours before sleep. The photoreceptors that worked all day rebuilding their light-sensitive outer segments do their primary repair during deep sleep. A blood sugar spike during that window competes directly with the repair process. Give your retina its recovery window. Stop eating before bed. Tonight.